Hi, in this session we will be discussing about the pseudo columns. The pseudo columns available in Oracle database. What do you mean by a pseudo column? A pseudo column is nothing but which is automatically available, implicitly available in the database, where we will not be creating the values. The values will be available implicitly or automatically by the database. Those are referred to as pseudo columns. In Oracle database, we have 5 pseudo columns: Rownum, level, row ID, curval and next val. These are the 5 pseudo columns we have in Oracle database. Curval and next val, these are the pseudo columns that are associated with sequence. We have already seen and used these 2 pseudo columns with sequence. When we were discussing the topic of sequence, there we have used curval and next val. The curval will give the most recently generated value by the sequence. Next val will give the next available value to generate by the sequence. Whatever the value is available readily to be generated by the sequence, that value is called as next val, and the value which has already generated, means in the past, the most recent one, that value will be given by or is called as curval. So curval and next val, these 2 are associated with sequence. Apart from these 2, we do have 3 more pseudo columns: Rownum, level and row ID. These 3 pseudo columns will be available with table. Table is a logical collection of data or logical structure. That is why these 3 pseudo columns are also logically derived values. But in this, the row ID is a physical address. Rownum, this is the sequential numbering, sequential numbers for the output of the query. That means sequential numbers for the rows that are displayed or generated by a query. These are not the numbers that are stored for each record inside the table. When we insert records into the table like 5, 4, 3, 2, 1, the row number is not like 1, 2, 3, 4, 5. Means row number 1 is for the first record which we have inserted as 5. Row number 2 for the second record which we have inserted as 4. It is not like that. Row numbers are always displayed for the final output. The final output of the query will have the row numbers in the sequence starting from 1. Row number is always a positive integer. It will start with 1 and it will continue. All these are sequential numbers. That is 1, 2, 3, 4, 5 like this. These numbers are only for the final output, not at the time of storing the data into the table. Next, level. Level is also a pseudo column which is available with the table's data, and again this is for the final output only. This will give the level of the record when we use the connect by clause, especially in hierarchical queries, or when we use connect by clause to generate the hierarchical reports. Then we need to understand the level of the record, whether it is in the first level, second level, third level and so on. For that purpose we use the level pseudo column. So when we use the connect by clause in the query, then if we use level pseudo column, then it will give the appropriate level value of that particular record. When we arrange the hierarchical structure of employees, based on the managers. The top level employee will have level 1. Immediate reportees of top level employee will have level 2. The next level will have level 3. Next level will have 4, and so on. So this is the pseudo column which will be helpful to find out the level of a record or employee in the hierarchical reports when we use connect by clause. The next comes row ID, which is the physical address of the actual row in the database storage. Row ID will be available with every table, but row ID will not be active unless we create an index on that table. When we have index, then row ID becomes very much active in the searching of data in the table. When we don't have index on the table, the searching will be based on the full table scan. When we have index on the table, then the searching will be based on the row ID, whether it can be index unique row ID or index range scan, index unique scan or index range scan. In case of index unique scan, it will use row ID values. Row ID is always unique. It has its own properties. Those properties we will be discussing in detail. Now let us see. Let us complete Rownum and level. Then we move on to the row ID. Row ID is a lengthy topic which we discuss later. Let us complete the practical session on row number and level. Rownum and level pseudo columns. Let us set our environment. I am closing other sessions. We just need only one session. Show user, we are in Scott schema. Let us select star from EMP. We have 14 rows. Now let us select row num, comma, row ID, comma, level from EMP. Level is invalid, connect by clause is required, so I am removing this as of now. Rownum and row ID. See, Rownum is always sequential, 1, 2, 3 up to 14. Row ID, it has given some value. About row ID we discuss later. As of now we are discussing about Rownum. It is sequential value. Now EMP order by salary. Let us take salary from EMP order by sal ascending. See the row number now. This is having row number 1, this is having 9, 12, this is 11, like this. Now descending. $1300 is always having this is 14, 13, this is displaying, however we have inserted the records in some order, it is taking the Rownum. Now let us use where Rownum equal to 1. It is giving 7369 for the salary 800. Rownum equal to 2. No rows selected. If it is giving based on, if the Rownum is physical numbering, if it is physical, see when you say Rownum equal to 1, it is giving like this. When you say Rownum equal to 2, it should give this record. It is saying no rows selected. That means it is not physical numbering. It is logical. If you say less than or equal to 2, now both are coming, 1600 and 800. Since it is logical, we cannot say equal to 2 or equal to 14, or even we cannot say Rownum is greater than 5, greater than or equal to 5. All this will fail. Less than will work. Less than or equal to we have seen. Less than or equal to 5. Less than 5. And equal to 1. Only these three options will work. Equal to 1 always will work. Less than any number will work. Less than or equal to 5 will work. Less than or equal to also will work. Let us try less than or equal to 25. We don't have data. We are selecting less than or equal to 25. Still it is giving only 14. If you use Rownum also here, Rownum along with columns, it is giving 1 to 14. That means since we are not getting Rownum equal to 2, greater than 5, greater than or equal to 5, equal to 5, equal to 14, the row number is not a physical numbering. It is a logical number. Next, let us see our level. Level can be used with connect by clause. See, select star from EMP. Manager employee number. Employee number is primary key, manager is foreign key. We can establish a relation based on these two columns to produce hierarchical report. When we produce hierarchical report based on these two columns, we can generate the level pseudo column value. Let us see, select manager comma employee number from EMP. We need to use connect by prior. In connect by clause, we can display the hierarchical report in two formats, top down and bottom up. So this we will see in detail about top down report and bottom up hierarchical report in connect by clause. As hierarchical query, we have a separate topic. In that topic, we will discuss more about connect by clause. As of now, we should know what is connect by clause. This is just to display the tree structure or hierarchy of data. Connect by prior EMP number equal to manager. Yes, and we can also use order by 1. Descending or ascending. Okay, descending. Is the top level. See this employee, he doesn't have any manager, he is the top level employee. Next 7369, he is reporting to 7902. Maybe we use distinct here, it is repeating. Yes, 7369 is reporting to 7902, 7566 is reporting to 7839. We got some hierarchical report here, but we do not know who is in level 1, who is in level 2, level 3, level 4, like that. In this case, we use the keyword level. We can remove this order by 1 based on the level. See, all these are level 1. Next, these are level 2. These are level 3. And these are level 4. This is how we can generate the hierarchical reports using level pseudo column. If we do not have this level pseudo column, it is very difficult to identify whether this employee is in first level or second level or third level and so on. When we use the level pseudo column, we can easily identify that this is the employee which is present in the level 1. We can analyze more on this, but that analysis we will do in our connect by clause topic. As of now, we need to know the level pseudo column. That is why we are coming to this connect by clause, because this is where we can use the level pseudo column. Without connect by clause, we cannot use level pseudo column. Here we can see some numbering 1, 2, 3, 4. Whether this numbering is proper or not, whether this level is correct or not, that we will analyze more in our connect by clause. But we can see some different numbers in the level 1, 2, 3, 4. Means level is also a pseudo column which can produces numbers sequentially based on their level. Next, move on to our last topic, which is row ID. It is a lengthy topic. Actually, row ID is a pseudo column. As we already know, it is a pseudo column. We will not be giving any values for the row IDs. The system, Oracle database, will automatically generate the row ID values for the records of the table. Row ID values will be generated automatically. Row ID is a physical address. This is not the logical value. This is a physical value. We can also fetch the data of a table based on the row IDs. During selects, we can use row IDs. During deletes, updates also we can use row IDs. especially to identify the duplicate records or to remove the duplicate records. We use the physical address which is row ID. When we use row IDs, it will be very easy to identify the duplicate or repeated or redundant data in the table, and we can easily remove them using row IDs. There are two types of row IDs in Oracle database. They are restricted row ID and extended row ID. Up to Oracle 8, we were using restricted row ID. Starting from 8i, they enhanced the restricted row ID to extended row ID. In 8i, they started using extended row IDs, and in 9i, they made it as full-fledged extended row ID. Starting from 9i, we have extended row IDs. So 8i has both restricted and extended row IDs, but starting from 9i, we are using only extended row IDs. We do have the backward compatibility to support restricted row IDs, but by default the row IDs what we are using starting from the version 9i is extended row IDs. But in 8i, we have both the options. While setting up the database, we can choose whether you want to use restricted row ID or extended row ID. Based on that, row IDs will be generated. But starting from 9i, the only option available is extended row ID. To support restricted row ID, we have the backward compatibility. They have provided one package which is dbms_row ID, where we can change the restricted row ID to extended row ID or extended row ID to restricted row ID. dbms_row ID package is used to manipulate the row ID values from one form of the row ID to other form of the row ID. Now let us see what is restricted row ID and what is extended row ID. Restricted row ID is 16 characters long. Means the length of the row ID value is 16 characters, whereas extended row ID is 18 characters long. The length of extended row ID is 18 characters. When it comes to in terms of bytes, restricted row ID will take 6 bytes, whereas extended row ID will take 10 bytes. Means the storage space of restricted row ID is 6 bytes, storage space of extended row ID is 10 bytes. Up to Oracle 8, we were using only restricted row ID. Starting from 8i, we started using extended row ID. From 9i, we have only extended row IDs. The length of restricted row ID is 16 characters. Length of extended row ID is 18 characters. Restricted row ID uses hexadecimal number system, that is base 16 number system, whereas extended row ID uses base 64 number system. Extended row ID uses base 64 number system. Restricted row ID follows hexadecimal or base 16 number system. Both the row IDs will be represented in varchar2 format. The representation of restricted row ID and the representation of extended row ID both will be in varchar2 format. In hexadecimal number system or base 16 number system, we will be using 16 different digits. They are 0 to 9, A to F, either uppercase or lowercase. 0 to 9, we have 10 characters, 10 digits. A to F, 6 digits. Totally 10 plus 6 equal to 16 digits will be using in the hexadecimal number system. That is, restricted row ID will be using only these 16 characters or digits in while generating the row ID. So except these 16 characters, no other character can be found in the restricted row ID. In extended row ID, since it uses base 64 number system, there will be 64 different digits or characters in this number system. They are uppercase A to Z, lowercase A to Z. Uppercase A to Z are not same as lowercase A to Z in extended row ID. But in restricted row ID, uppercase A to F and lowercase A to F are same. They are not different. But in extended row ID, uppercase A to Z are different from lowercase A to Z. So uppercase A to Z, 26 characters, 26 digits. Lowercase A to Z, 26 digits. 0 to 9, 10 digits. So 26 plus 26 is 52, plus 10 is 62, and then plus and slash 2. 62 plus 2, total 64 digits will be visible or can be used in the extended row ID. We can see these characters in our practical session, or where after this 64 again the number system will be repeated from capital A again. The restricted row ID has 3 different parts in that. Since it has 16 characters, it has 3 parts. First 8 characters is one part, next 4 will be second part, next 4 will be third part. So 8 plus 4 plus 4. This many characters will be present in each part. In extended row ID, it has 4 parts. 6 plus 3 plus 6 plus 3. First 6, one part, next 3, second part, next 6, third part, last 3, fourth part. So restricted row ID has 3 parts, extended row ID has 4 parts. When it comes to the restricted row ID, the 3 parts are data block number or data block ID, the sequence in the block or the row number in the block, and the file number, data file number or file ID. The first one is block number, second one is row number, third one is file number. In extended row ID, it has 4 parts. The first one is data object number, second one is the relative file number of the object, third one is data block number, the last one is actual row number in that block. Data object number, data file number, data block number, and the actual row number. If you take an example of restricted row ID, this will be visible like this. First 8, next 4, next 4. In this, first 8 A's represent data block number, next 4 B's represent the row number in the block or sequence in the block, the last 4 which are C represents the file number, data file number. In extended row ID, the example of extended row ID looks like this. First 6 characters of A represents data object number, next 3 characters of B represent data file number of that particular object, third part 6 characters of C represent data block number, the last 3 characters which are D represent the actual row number in this particular block. If it is extended row ID, the restricted row ID restricted row ID is unique at the entire database level. In one database, the row ID will not be repeated again. It is unique for that entire database. When it comes to the extended row ID, it is unique at table space level. It is unique within the table space. When we go to the second table space, again row IDs will be repeated. So there is no consistency of row IDs within a single database. They are consistent within the table space only. In one table space, row ID will not be repeated in extended row ID. But in restricted row ID will not be repeated in that particular database. It is unique at the database level, whereas extended row ID is unique at table space level. Now, if you take the extended row ID, the first row ID will be all A's, 18 character long. Last row ID will be all slashes, which is 18 characters. Now let us see practically how the row ID looks like. We need to connect to the schema where we have at least 64 number of records in the table. Then only we can see all the row IDs in sequence. So one such schema is HR schema. We made password for HR schema as HR only. It is connected. If you see select count star from employees, there is one table employees in HR schema which has 107 records. That means if you want to see the extended row ID, we need a minimum of 64 records. Then only we can see the sequential row IDs. So this employees table has 107, so that we can see select row ID from employees, order by 1. We are ordering in ascending order based on the row ID. Now let us see the row IDs. It is 107. Let us start from the beginning.